Good people, welcome to JJ Tech Tutoring. In today's video, we'll be talking about electrical machines. So I'll be solving tutorial questions for you, since I told you that I'm just going to be your tutor in any module that I think I'm best in, and that will be electrically related, right? So today I'm going to be solving excitation and induced EMF in a coil. So we're going to talk about the induced EMF, we're going to talk about the back EMF. So the difference is only the induced EMF is just for the generator, and the back EMF or counter EMF it's for motor. So first thing first, I would like to introduce you guys to the formula, right? So this is the formula of our induced EMF, right? Divided by 60C, right? So one thing that we should know is that this is just a general formula. This is just the main formula that we're gonna get our formula out of it, right? Now, what we can say now is you need to know the kind of variables names, right? So you need to understand that this Z stand for what, this N is for what, and P is for what, and then this one, obviously, you know, that's flux, and then this one, right? So what we can say now is we need to understand N is the armature rotation. So it's the armature rotation, right? So it is measured in revolution per minute, right? RPM, right? Then Z is our total number of armature conductor, right? So you can call it number of conductors, right? Because when they're asking questions, they can ask you to find the number of conductors, right? Now P, you can just assume those are number of pair of poles. This is very important. This is very important to can pick up certain things, because there lies the truth, there lies misunderstanding, there lies arguments, right, among students. Pair of poles, right? We're going to talk about that, right? Now C is just the number of parallel path, right? So now, as things stands, we didn't have to talk about the lamp and wave, right? We're going to talk about the lamp and wave, right? So for a lamp, C is equals to 2P, right? That's for a lamp. C is equals to 2P. Then let us take our main formula, right? Divide by 60C, right? Now we have to substitute this, because now we are talking about a lamp, right? We have to substitute this, and then don't worry guys, I'm going to do tutorial questions for you. Now I'm trying to introduce you to formulas, then from there I'm going to do all the tutorials for you. And then fortunately for students who are studying at the University of Johannesburg, because the materials that I'm using are actually from the University of Johannesburg, and the questions that I'm using, some of them are from there, right? Now E is equals to, EMF is equals to 2 flux, number of conductors, and then armature rotation speed, and then poles divided by 60 multiplied by number of parallel path, right? Now number of parallel path for lab is 2P, right? Now 2 flux Z and P divided by 60, then 2P, right? Now we know that we're going to cancel this and this and this and that, so that means our final formula will be, so this is the formula that you can use, right? So this is the formula that can be your final formula, right? So this is the formula that when they're asking you about a lamp, then you have to go for this, right? Now let's talk about the one for wave. For a wave, your number of parallel paths are 2, right? So number of parallel paths are 2. So you can just say EMF is equals to 2 flux ZNP divided by 60 C. And from there we have to substitute what? 2. So it's 2 flux ZNP divided by 60. Then we put 2 here, right? Then before we can multiply this 2 and this 60, we can just cancel it out. Then from there, that means the formula will be flux ZNP divided by 60, right? So this is our actually formula for this question, for this wave. So for a wave, this is the formula, and for a lap, this is the formula, right? And now that's it. So that's it for the induced EMF or back EMF. Like I said, guys, when you are considering or referring to the induced EMF, and then the question talks about motor, so that means you need to call that as a counter EMF or a back EMF. A back EMF tells you that whatever EMF that is being used there or that is induced there, it is induced in a motor. So back EMF is the voltage that is induced in a motor. Then induced EMF then simply is for a generator. Right, now let us then solve tutorials that I have prepared here for you. Right, now a 6-pole lap, very important. A 6-pole lap connected to DC generator, very important, has a useful flux pole of 0.045 Webers. If the no load voltage at 400 RPM, so we know that this is our N, is 300 volt. So that means this one is our induced EMF. Find the conductors on the armature periphery. So as I told you guys that when they are looking for total number of armature conductors, they can just ask you to find conductors. So that means now you should know that they are looking for total number of armature conductors. Right, now they are talking about lap. So automatically I have derived the formula for you. I don't expect you to expect me to derive the formula again. So E is equals to flux N Z over 60. NZ over 60, right? Now, what is it that you need? You have got E, that is 300 volts. You have got N, that is 400 RPM. You have got flux, that is 0.045. Then what don't you have? That's Z, which is the conductors. Right, now we have to make Z subject of the formula, right? We have to make Z subject of the formula. So this is our Z, right? So it is equals to 300 multiplied by 60 divided by 0.045 multiplied by 400. Then what's the answer? That's 300 multiplied by 60 divided by 0.045 multiplied by 400. So that's 1000 conductors. Right, so we have got 1000 conductors. So that's problem 1. Now problem 2, an 8-pole wave connected to DC generator has 100 armature conductors. So this is our Z, and flux pole of, this is our number of flux. At what speed must it be driven to generate 500? So at what speed must it be driven to generate? So that means at what speed must it rotate, right? Now, what is it that we have here? This is another important line, and this is also an important line. Right? That means now this shows that we're dealing with a generator. Right, now, number of poles are always in pairs, right? Number of poles are always in pairs. Like I told you guys when I was introducing you to the formulas, I talked about P being the pair, right? So that means now it is always pair. So it's always pair. So that's 8, right? It's always pair. So that means what we need to use then is 4. There is a pair of, if now we talk about, maybe for an example, if I give you 8 shoes, right? So that means now when we are counting when we're counting them, then we can say if I give you 4 pair of shoes, right? That means now when we're counting them in a singular way, then we're gonna say you have got 8 shoes. But then now when we're counting them as pairs, those are 4, right? I'm not sure if I'm making sense. So when they give you a pole, so that means you divide that by 2 to make your life easy. Then you get the straightforward pole, right? Now, this is wave. So for wave, it's EMF is equals to P N Z divided by 60, right? Because I've already derived this for you. Now, E is equals to, what are we looking for? We're looking for N, because they said at what speed must it be driven to generate 500 volts. Right? Now we have to make subject of the formula. N, subject of the formula. So it's E multiplied by 60 is equals to N, then divide by flux PZ. Right? So then the speed is equals to E times 60 flux PZ. I wanted to put it in my right hand side. Right? Then you've got 500 EMF times 60 divided by 0.035 flux, then 4 as our number of poles times 1000 conductors. Therefore, N is equals to 500 multiplied by 60 divided by 0.035 multiplied by 4 multiplied by 1000. Then you're gonna get 21429 revolution per minute. Right? So this is your final answer. This is your final answer. Now, let's go to another question. Right? Problem number 3. Now, the armature of a 6-pole DC motor. So that means now here we are dealing with counter EMF or back EMF. There's a wave winding containing 650 conductors. So that means now we have Z. Calculate the back EMF when the flux per pole is 0.055 webers and the speed is 300 rpm. Right? Now, at this point, we have number of speed in the rotation speed, and then we have number of flux, and then we have number of poles, and then we have our Z, number of conductors. Right? Now, what are we looking for? Straightforward. We're looking for, there is no need for us to play around with our algebra trying to make whatever subjective formula. Now we're going to just plug and play. So as I said, guys, that when you are given number of poles and you are following that formula that I gave you, then every time for a wave you need to divide your poles by 2, right? Because they come as pairs. So those are pairs, right? Now poles are equals to 6 divided by 2, that's 3, right? Then E is equals to NPZ divided by 60. Then number of flux 0.055 multiplied by speed 300 multiplied by, then conductors 650, then poles 3 divided by 60. Right. 0.055 multiplied by 300 times 650 times 3 and 60. Then the answer is 536.25 volts. So that's your answer. That's your answer. So this is basically what I had for you for today, right? And then next time I'm going to come with other soft brush DC machines tutorials. So I'm just going to be coming up here with tutorials. I'm not going to teach you guys theories. Those are for your lecturers. So this channel is only for tutoring purposes, right? At some point, yes, I'm going to come with teaching you the power generation, how the electricity is generated in different stations and all. But then my focus and my goal is to make sure that I help you master and I help you answer the questions in your exams, in your tests and everything. So I'm just gonna do that, right? Maybe later in life, then I'm gonna be able to be a professor or a doctor. Then I'll be able to help you with theory part. But then for now, let's focus on calculations. Don't forget to subscribe, like, and share. Thank you.